Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to talk about a small signal model of MOSFET transistors. This is a typical small signal model which is valid for NMOS and PMOS. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button and also the notification bell. So let's jump into it. These are the NMOS and PMOS transistors. As you see in the left hand side, this is NMOS and this is PMOS. Most of the times we start with NMOS transistor, but here there is no difference between NMOS and PMOS for small signal model. For a small signal model where we have gate, we have drain and we have source. For a small signal model, between gate and source, you have to consider VGS, which is a parameter that is varied in every circuit. And there is a dependent current which is called GMVGS. Well, this is GM times VGS. And what is GM? GM is a transconductance for this amplifier, which is, we can define it as run VGS, GM is round I drain with respect to VGS. This is a definition for GM, transconductance. With transconductance, you can somehow convert the voltage into the current in this transistor. And VGS is a variation parameter. This is a small signal model for this transistor. And keep that in mind, for PMOS, you can use this as long as you get the plus sign of VGS in gate and negative sign of VGS on source. And by choosing this voltage polarity for VGS, you have to choose the direction of the current of GMVGS from drain to the source. So sometimes in some problems I use this approach onto the circuit. I mean that this is plus minus VGS and this is a drain current for a small signal model. This drain current is GMVGS. And again, for PMOS, I had to choose the plus sign on the gate, so, and the negative sign on the source. This is VGS for PMOS, and again the direction of the current from drain to the source. This is GMVGS for PMOS transistor. You can get another approach for PMOS. Imagine this is a PMOS, gate, source and drain. You can choose this approach as well. You can get the VGS from source to the gate with the plus sign on the source. Then you have to change the direction of the current from source to the drain, GMVGS. But this is some kind of a confusion, and as you can see, you can have both NMOS and PMOS with the same small signal model. This is a really great point to notice that, and I mentioned this from the book Fundamentals of Microelectronics by Behzad Razavi. So, and another thing, if we in this scenario we neglect the channel length modulation. If you add channel length modulation, you can just have this resistor between drain and source, which is called RO, or sometimes we call it R drain source. And R drain source is defined as 1 divided by lambda I drain. Lambda is something like 0.1 volt to the power of -1 for lambda, and it is different for NMOS and PMOS. Okay, this is just a simple example, and as you can see, by having the drain current of NMOS or PMOS transistors, you can have a small signal parameters such as GM and R drain source for this small signal model. But VGS is varied and you have to use VGS to calculate the small signal parameters such as for amplifiers such as gain or input resistance or output resistance, something like this. So just to recap this video, for a small signal model we have this one as a small signal model, a simple small signal model which is neglected the channel length modulation. If you consider the channel length modulation, you add RO between drain and source, and these models are varied for NMOS and also PMOS. I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friend. Thanks for watching.